All right, let us now discuss how Stuxnet is being loaded. Stuxnet drops resource 242. We saw that before, mrxls.cls.sys. That's from Export 16, and that's a driver we have discussed in the past. This is a driver digitally signed with a compromise certificate, and that certificate was revoked July 16, 2010. Since this is a driver, this allows Stuxnet to be executed every time an infected system boots. The driver is registered as a start service by creating that specific registry key you can see here on the slide, and that allows Stuxnet to be loaded early in the Windows boot process. And the early part is important because this is loaded before the antiviruses have a chance to be loaded. Drivers are being loaded before the actual software processes. This again allows Stuxnet to be loaded after you restart the system, so you don't have to reinfect the machine after a reboot. And the driver will inject and execute copies of Stuxnet into specific processes similar to what we have discussed before. Before we saw how Stuxnet can propagate on the fly by inserting a USB drive that's infected. It can load itself all through network propagation, but then it also, during installation, it installs this driver that allows it to be reinstalled whenever you restart your computer. So this driver contains an encrypted data block, and after decryption, this would have a registry key value pair and other things. That's normally the string you see on the slide. And what this allows Stuxnet to do is to read the value, the binary value, decrypt the value, and then create the files that Stuxnet needs. Services.exe, this is the file to be injected, and this is the module to inject. So this actually will take the whole Stuxnet DLL. This has been dropped, remember, from Export 16 that was dropped before. Also, Siemens specific processes are injected. The S7 TGT OPX.exe will also be injected with a copy of Stuxnet DLL. The same with the CC Project Manager. This is the WinCC database software, and also Explorer.exe would also be infected as well with this OEM7m.pnf module. So the whole process happens when the system starts, and this driver ensures that these processes will be injected with these files that contain actually Stuxnet. So Stuxnet is now injected, and it is part of the system I can run with administrative privileges in the system. Now the next of what Stuxnet needs to be constantly updated and also be, while it's performing reconnaissance, get new instructions from the attacker would be the command and control. Stuxnet contacts the command and control on port 80 and through HTTP. And this is the reason behind the selection of regular HTTP traffic on port 80 is to ensure that firewalls won't be blocking the traffic, because this is legitimate. Well, this looks like non-suspicious internet traffic. So we know of two command and control servers that have been used in known samples. One is this one, mypremierfootball.com, and the other one is todaysfootball.com. So these URLs in the past would point to servers in Malaysia and Denmark, but since Stuxnet was discovered, they have been redirected to make sure that Stuxnet won't propagate further. Still, Stuxnet has the ability to update itself with new command and control domains through that specific file here that resides in the Windows directory in the inf subdirectory. So looking at the right side on how the command and control works, so from the compromised computer that Stuxnet has executed, it will do a simple network check. Do you have network access or not? Because some computers are not connected to the internet. And then if the network access is okay, then it would send the payload, it will send information about the computer through the data component of the URL. And we'll see that in the next slide too. It will send information out, and then the command and control server will receive the information and respond back either by asking to execute a routine, so the attacker can execute pretty much any code on the compromised computer, or it would ask, it will just provide back an encrypted binary code to to the client, to the compromised client. So this is how the command and control works, but let's see that in more detail. So the information that is being sent, let's go back. So here, Stuxnet is sending basic information about the computer. This information is being collected by one of the exports, export 28, and that payload would contain a lot of information, as you can see on the right side of the slide, from machine and domain name, operating system major, minor versions, whether the service packs or not. Again, all these things affect which vulnerabilities are present in the system. We expect newer version operating system to have patched some of the vulnerabilities. And also there's information about IP addresses and interfaces of network, and some Siemens-specific code, copy of this S7P string from this data component. So this is the basic information sent, and also the flags that here at offset 11 of this payload will indicate to the attacker whether these registered values are found, one of the two, and that means that this computer runs a step 7 software. So that means that's probably a computer of interest, and that's a computer that a PLC, a Siemens PLC, is connected to it. So after the payload data is being collected, is then XORed with a byte value FF, and then another export will take this information collected by export 28. Export 29 will take this information and send the payload to the target server, as we saw before. So export 29 first sends the information out. It checks, as we saw before, connectivity. It checks connectivity by checking for two specific web servers. One will be windowsupdate.com, and the second will be msn.com. If a connection is established, that means that the specific computer has network access. So the test is passed and the network packet is built. This will have information that we saw from before, this DWORD, some other information, and then the IP address and the payload. The payload is then XORed with something that in a way looks like a one-time path, right? You XOR with a static 31-byte long string, and this kind of hides, because here, from the previous slide, right? So this is plain text. So you're trying to hide that you're sending information out that would look suspicious. So you're trying to kind of encrypt it by XORing with this static 31-byte string. So once you kind of encrypt it, you send it as the data parameter in the URL. So when you access this website, this mypremierfootball.com, after the index.php, you would send this data parameter, and then you would put your payload here. So when you send your URL out for access, the data sent will contain all the data we just discussed. And I'll repeat and emphasize that using the HTTP protocol and pure ASCII parameters, as you see here, this is plain ASCII, that's a very common way to bypass firewall blocking rules, because this is expected network traffic, and very often when you talk to a website, you click on something, or you're sending information about what you want the website to be responding to. So this is how Stuxnet is sending data to the command and control server. And then the same export will be receiving also a response from the command and control center, and the response payload is located in the HTTP content section. So before it was just ASCII data, but now what you get back is it's binary data, and it's also encrypted somehow with a different XOR, a different key, the one you see here. And then once you decrypt that with this key, then you have this format: the modules, the payload size, command byte, and payload module. So depending on the command byte, you either run the payload in the current process, or you run the payload in a new process via RPC. And after you do that, you load payloads export one, whatever that is being loaded. So that means that you can send any binary to the Stuxnet compromised host, and after the Stuxnet will receive the information, will receive the binary back, then it will load export one that can be any code. So that gives the attacker the ability to execute any code on the infected machine. And that code can be used for anything. It can be used for further reconnaissance, for updating Stuxnet, or anything the attacker would like to do. So that's full backdoor functionality with the ability to upload and run any code on an infected machine. Stuxnet also had the ability to hide itself. And to do that, it had some Windows rootkit functionality. So to hide itself from the removable drives, that was one of the ways Stuxnet would be propagating. Because if you insert the USB and you list the files, that's very common use of a USB drive. You see what's inside and you see weird file names, then you may suspect that something is wrong. To do that, to prevent the files from being shown to the user when the user was browsing the contents of the USB drive, Stuxnet, through this export 16 we saw before, it will extract the other driver, the mrxnet.sys. So this driver will be again registered as service and will create that registry entry. And what it did, it was also signed with a legitimate digital certificate, so you wouldn't get a message from Windows that an unsigned driver was installed, and it would remove it or notify the user that something is wrong. So after the driver is being installed and it executes in the background, it scans the file system for the following objects: NTFS, FAST, FAT, and CDFS. So what this is actually doing is that it monitors the drives for specific file system objects, and then when this object is being inserted, for example, you insert the USB drive that has an NTFS file system, Stuxnet is able to intercept those requests. And these requests can be read-write to these either USB drives, but it could be also CD-ROM devices as well. So the driver is monitoring these IRPs, but is focusing on the directory control ones, and in particular the directory query notifications. What does that mean? So these requests are being sent, for example, by Explorer when you're trying to browse the contents of the USB drive. And when you do that, then Stuxnet is intercepting this directory query, and it does something specific to hide its own files. So what it does, it ensures that there are two types of files that will be excluded from a query directory result. They will not be returned back to the user when the user is browsing the contents of the drive. So what the types of files that are filtered out are any file with a .lnk extension that has a specific size, very specific size, that includes one of the 0 days that was exploited by Stuxnet. And any file that is named with WTR and some 4 numbers. The sizes are also fixed 4 kilobyte to 8 megabytes. And the sum of those 4 numbers, modulo 10, will be 0. For example, this 4132 here, file name you see, if you add those digits, you get number 10. This modulo 10 will give you 0. So this is a way to have special file names there. So with these filters, we'd exclude these files, right? So if you had those 6 files in your drive, those 4 LNKs, for example, because they had that specific byte size, they won't be shown to the user. And same with those TNPs, because if you had 4132, that's 10, 4141 is also 10, 10 is also 0. So these will be hidden from the user when browsing the directory.